All right, still continuing with some more examples here. Actually, right now, I'm not going to use any new rules. The catch to this one and the next one basically is just doing some rewriting. Okay, on this one, you got this fraction. Of course, you've seen other problems in which we've had fractions, like for instance, this problem that I just had finished working. See, I've got the fraction here, but my denominator is just a number. So in that case, you're always just going to be pulling it out front, and making a constant multiple with it, just making the fraction out front. Now that's not the case here because I don't have just a number on the bottom. Now you are not allowed to take the derivative of the top and take the derivative of the bottom. Okay, you can take the derivative of things that are added and subtracted individually, but not divided. Okay, now a little bit later we are going to learn a quotient rule in which you could use the quotient rule on this one. But actually, if you take one step of rewriting, then this problem can be done without quotient rule. And anytime you can rewrite something and not use quotient rule, you're going to prefer to do that because quotient rule takes a little while to do. Sometimes we don't have an option though. So the rewriting that I would suggest that you do here is actually just divide each of those terms, each of the terms on the top by the x. So if I do 2x squared over x, then you're going to be able to cancel this x that's on the bottom with one of those, which means this divided by this would just simplify to be 2x. Okay, doing the same thing here. If you divide this term by this, your x's are going to cancel out and you're just going to have the minus 3. Now, doing this term divided by x, nothing's going to cancel out. Okay? Now, we still have one more step of rewriting that we are going to need to do, and that's because of this term right here. Again, you can't do the derivative of the top and the bottom individually for the same reason that I explained here. You're going to need to rewrite this term. So we've got our 2x minus 3 plus. Now the x is understood to be the first power, so take it and move it to the top. So that will give us x to the negative 1. But see, by rewriting it this way, you can now use your power rule. So now starting your derivative. Okay, so here's my x to the first power. So remember what I told you, if x is to the first power, then once you go through the power rule, it's just going to end up being the coefficient. So that's just going to end up being 2. Of course, the middle term here being a constant, the derivative of a constant is just 0. And again, you don't have to show me this. You can just jump straight from this term to this term because having the minus zeros, is not going to change anything. All right, using my power rule here, I bring my power to the front, times x, reduce my power by 1. All right, so just cleaning this up a little bit, simplifying things. Again, this would just be 2. Now we need to do some rewriting here. First of all, this is adding a negative, so we can just change this to subtraction. You will want to move this to the denominator so that you will have that written with a positive exponent. So this would be your derivative. Okay, next one. Now this one isn't one that we're going to have to rewrite, but we haven't worked with any problems in which our exponents have been fractions. But it's still just going to be the power rule. You just have to learn how to deal with the fractions. Of course, you've got a calculator that will help you out with finding that. So f prime of x. Okay, so using my power rule, take my power, bring it to the front. But then I have to decrease my power by 1, so you're going to have to do 2/3 minus 1, and that's going to be a negative 1/3. Okay, minus, now remember these are being added and subtracted, so you are allowed to take the derivative of those individually. Okay, so next term, bring your power to the front, times x, and again reduce by 1, so 1/3 minus 1 is going to give me a negative 2/3. And then the derivative of a constant, as we've already seen, is just 0. Okay, simplifying this, or basically just kind of rewriting it, cleaning it up so it has just positive exponents. On this one, you need to take x to the negative 1/3 and move it to the bottom so that you'll have a positive exponent. Same thing here. And of course, you wouldn't have to bother writing the +0. Now, some of the answers in the back of the book may take this a step further and actually get a common denominator, which that's not something that I would require you to do. Okay, now here's another rule. And this is getting into, obviously, some of the trig. Now, as far as right now, we're just going to be working with sine and cosine. If you have to take the derivative of sine, the derivative of sine is just going to be cosine. And the derivative of cosine is going to be negative sine. So make sure, of course, here that you don't forget the negative. So the next couple of examples will be using each of these rules. So derivative of sine is cosine, derivative of cosine is negative sine. Okay, so on the first one, of course, they've switched the variable here to theta, which what variable they use doesn't matter. Now, you're not going to have to rewrite this one in any way, so we're ready to start our derivative. Now, just like we would have numbers that were multiplied by our functions a while ago that I kept referring to as those constant multiples, you've got exactly the same thing here. This is just a constant multiple, so all you have to do is 3 times the derivative of sine. Of course, the rules that I just gave you, derivative of sine is cosine. So, I mean, there's really not anything much that you can do. I mean, leaving your answer like this is perfectly okay. Of course, when you're dealing with multiplication in this case, most of the time you just don't have the dot there, you know, to indicate the multiplication. Okay, number 2. All right, so we've got a difference. We have something minus something, so I am allowed to take the derivative of those two terms individually. Okay, now this is, you know, just an algebraic term that we've already been dealing with. This is x to the first power. So remember, if you go through the power rule, it's just going to end up being the coefficient. Okay, minus. And now I've got to take the derivative of cosine. Now the derivative of cosine, though, is negative sine. So because it is a negative, I am going to put it in parentheses because what you have is minus a negative. So you can rewrite this then as plus. So 2 plus sine x would be your answer.